Hello students, good morning. See, in a previous video we have seen the information about how to draw distance time graph for uniform motion. See, all of you know that what is mean by uniform motion and how to draw a graph with the help of given data. Uniform motion is nothing but if the object covered equal distance in equal time interval, then that object is said to be in a uniform motion. What is the conclusion of our previous graph? The conclusion of our previous graph is nothing but we got a straight line for that graph, for distance time graph, and that straight line indicates the object or the given data or the given car is in uniform motion, because in that graph we get a straight line. See, in this video we are going to learn, or we will discuss about second type of graph, that is nothing but the distance time graph for non-uniform motion. See, what is our heading? Distance time graph for non-uniform motion. See, first of all I want to tell you what is the non-uniform motion. All of you know that we have already seen all the concepts regarding motion. See, non-uniform motion means what? When the object changes its place with respect to in equal time interval with unequal distance. Are you getting this? Equal time interval, unequal distance known as non-uniform motion. Equal time interval, equal distance known as uniform motion. See, in this video we are going to learn how to draw a distance time graph for non-uniform motion, and based on that graph what is the conclusion of our given activity. See, here is the one activity for you or given data for you. See, what is the data? The following data or the following table shows that distance covered by a bus. See, this table shows that distance covered by bus in equal time interval. See, here is the time in a equal time interval. Then draw a graph for distance against time. Means what kind of graph we want to draw here? Distance and time graph. See, then distance against time. Here is the full stop. Again, the taking the time along the x-axis and taking the distance along the y-axis. Here is the activity. See, here is the activity, a distance covered by a bus in a equal time interval, and here is the we want to draw a graph for a non-uniform motion. See, here is the given data. See, this is the time interval. Time first is the 5 seconds, second is the 10 seconds, then 15 seconds, then 20 seconds, then 25 seconds, 30 and 35. Means if you can observe, the time changes or the difference between the time is 5 seconds, 5 10, 10 5 15, 15 5 20. Means time is in equal interval. See, but the distance covered by that bus is not equal. See, when time of 5 seconds distance covered by that bus is the 7 meter. After that, when time is the 10 second distance covered by that bus is a 12 meter. See, difference between 7 and 12, 4 meter. Again, difference between 12 and 20, 8 meter. Distance between 20 and 30, 10 meter. Distance between 30 and 41, 11 meter. See, distance between 41 and 50 is how much? 9 meter. And distance between 50 and 58 is how much? 8 meter. Means if you can see here, the distances changes with unequal distances. See, means time is in equal interval, distance is unequal. Such type of condition when occur, the motion is said to be non-uniform motion. Therefore, based on that activity, we want to calculate the graph for distance time graph. But what kind of graph? Non-uniform motion. Let's see. First of all, in graph, we draw axis for that graph. This vertical line is known as y-axis. Horizontal line is known as x-axis. All of you know that. We have already seen in a previous video lecture when we draw the graph for uniform motion. See what kind of scale taken here. See, on a x-axis, time taking along the x-axis. Time on x-axis and distance on a y-axis. Therefore, I can write here time. What is the unit for time? Is a second. And here is the distance. And what is the unit for distance? Unit for distance is the meter. See? Clear? Now, scale of this graph, which is very important point of graph. If you didn't draw scale, you lose 1 mark. For scale, there is a compulsory 1 mark. See, on a x-axis, time. How much difference in a time? 5 seconds. Therefore, I write here the scale on x-axis is 1 centimeter is equal to 5 seconds, and on y-axis 1 centimeter is equal to how much? See, now here is the unequal distances. Then how we can write the scale on y-axis? See, here is the difference is a 10, here is the 11, here is the again 9 to 10, here is the 8 and here is the 4. Therefore, the scale taken here, I write here 1 centimeter is equal to 10 meter. 1 centimeter is equal to 10 meter. Now, here draw a scale on a graph. See, here is the 0 point. Here is the 5 second time. Here is the 10 second time. Here is the on 1 centimeter axis. Here is the 15 second. Here is the 20 second. See. Now, I write here the scale on x-axis. That is nothing but the distances. What kind of scale I write here? On y-axis, 1 centimeter is equal to 10 meter. Therefore, here is the, I write 1 centimeter, 10 meter. After that, how much? 20 meter. After that, 30 meter. And after that, 40 meter. And in between these, we can draw these point. All of you understood how the outline is drawn? See, now we start to plot a graph. What is the first point? See, time against distance. The 2 point means x-axis and y-axis intercept in between 2 points, that is nothing but the 0 point. See, first point is the 0 and 0. So, I draw here a first point which are present on a 0. Very easy. Next, how much time here? 5 seconds. And what is the distance when 5 seconds? Distance is a 7 meter. See, here is the 5, here is the 10. We can draw the point of 7 here. After that, how much? 10 and 12. Time 10 and 12 means 2 points. 10 after 2 points we write here. See, after that how much? 15 and 20 means this point. After that 20 and 30, 20 and 30. Now we join these all points. See, first, second, third, fourth and fifth one. See, this kind of graph we get for non-uniform motion. See, what is the conclusion based on this graph? We got here straight line? No, we does not got straight line. We got a curved line. See, all of you can see here we got curved line. In a previous video, in case of uniform motion, we got straight line, and that straight line, what is the indication of that straight line? The straight line indicate uniform motion. In this video, based on this data, we got a curved line, and this curved line shows or indicate the car or the object is in non-uniform motion. What is the conclusion? Conclusion of this graph is the object we can write here, we got the curved line. In previous video we got straight line. In this video we got curved line. Therefore we can write here this curved line indicate the object is in non-uniform motion, or the graph is for curved line indicates object is in non-uniform motion, and the graph is for non-uniform motion is proved. Why? Because we got the curved line. See, next information we will see in the next video. Thank you.